Okay, so we have alternating layers here, or beds. There's hard sandstone, and in between the sandstone layers, there's a much softer mudstone, or siltstone. It's finer grain material. Now let's think about what that means for the depositional environment. Now these mudstones are full of microfossils. These are tiny shells you need a microscope to see. So these forams indicate a marine environment, fairly open ocean. And the grain size, the very fine grain size, indicates low energy, quiet water, because silt and clay will only settle out if the water is moving very slowly or not at all. So these alternating beds of sandstone and mudstone indicate changing energy conditions out in the open ocean somewhere, quiet water, and then a fast-moving current coming in. There are periodically great submarine avalanches that come tearing down the slope, and they mix up water and sediment into something called a turbidity current. And these race down the slope carrying all kinds of coarse material and then spread out in a big fan or out on a plain. And they can go for many miles. In fact, one famous one happened back in 1929. There was an earthquake in the Grand Banks off Newfoundland, and it triggered a turbidity current that cut submarine cables sequentially as it moved out for 400 miles. So these can be big events. And these beds here are just the sort of thing that you would expect to be deposited by a turbidity current.